Hey, look up, please. No one talked. No one talked. Okay, I'll come back. Okay, just a reminder, so no one look up, make sure no one misses this announcement. Remember, we're going to do these two today in class. So we'll do that in a minute. But the other 50, the multiple choice, when you show up to class on Thursday, I will collect the Scantron. I'll run the Scantron. Whatever this says, that's your score for this quiz. Okay? Everybody understand? Awesome. Okay. We're going to do this one together. So here we go. It says the equation of a line tangent to the graph of f. I have found in this class that most of the time it's not really necessary to know what the graph of f looks like. So I don't really spend time trying to figure out what f looks like. I just pull out my old reliable favorite picture and declare that to be f. I figure Albert Einstein is famous for doing all kinds of strange things that weren't possible, so why not me? So he'd imagine strange things like elevators in outer space and such. Like, you know, here's that, whatever. Okay. Let's see. Equation of a line tangent to the graph of f. So extra credit. Originally, you can tell me how many different tangent lines does f actually have? Show me your hand. How many different tangent lines could we draw on the graph of f? Tristan? How many knew it? Point, 2 for Tristan. They want the specific tangent line that is located here. Okay, huge idea. Please raise your hand if you know. What is the purpose of this equation? You've got to have this memorized. If you don't, you need a flashcard. That's why they're on your desk. What is the purpose of this equation in any problem? Why does this equation exist? What's its purpose? If you're not raising your hand, make sure you make a flashcard. If you don't, I'm not kidding. If you don't know this, you're starting at half credit on the next test. Not because I have to give you half credit, because I know you'll miss half of them. So, hey. 2 points for that. I kind of want you to remember just a little simpler way for perhaps. But then,
you find the tangent slope at any point.
2 points, but no. The main, I would not. It's not wrong really, but I would not say that the main purpose of this is to do that. So let's go, Rachel.
Is it to find your y's at specific points of x?
Yeah, this f is nothing more than a bunch of xy pairs. You can do it either way. You can plug in an x, find a y, or you can plug in a y and find an x. How many knew that? 2 points. Question. Think of it this way. We're going to get Allison to put her phone away though.
Sorry.
She has 2 of them now.
Yes.
How exciting. Okay, now I've lost all train of thought. So we'll have to get Allison to pay me some tickets now. Raise your hand if you know how many points. Okay, when I say point, how many numbers am I talking about? Hands up, come on. When I say point, how many numbers am I talking about? Like a point is how many numbers? Brendan?
2.
2, always. How many knew it? 2 points. How many points does f have? Show me your hands, come on. Every point's an xy pair. How many points does f have? Right? Shoot. Chase. How many knew it? 2 more. So, look, it's really simple. No one wants to make a list. Don't talk, focus, come on. No one wants to make a list that has an infinite number of items in the list. It's not possible. So instead, we make a formula. But the formula is just the list. Okay? It's just the list. We good? All right. We want the equation of the streamline. So you must memorize this pattern. Okay, H is not special. I called it H, could have called it G, Q, L, Y, whatever. Okay, you must memorize the pattern. You must also memorize the meaning of the items in the pattern. Question? Please.
Okay, so the x1 is like a point on the line that we choose. What's just the x?
Oh, awesome. Let me kind of talk with you, and I think this will click. So right here, this equation, if you wanted to find, like we said, this is really just the list. So if you wanted to find the y coordinate when the x coordinate is 3, what do you do?
Plug in x, or plug in 3 for x.
Right. So I put a 3 here, I put a 3 here, I compute, and I find y. Fair? If I knew that the y coordinate was 10, I could put a 10 here and then rearrange and find x. You with me?
Yeah.
Okay, in this equation, the same is true. We're going to put a number here, here, and here. This is going to remain x, this is going to remain y, for the same reason it did up here. So you can plug in an x and find a y. That's all.
Yeah.
Good question. 2 points. Please.
So would you find the derivative of the first one to begin?
2 points for Mikkel. Raise your hand if you know why she's doing it. It's right. Like finding this derivative is a really, no, I shouldn't say that. It's a good next step. So why do we do that? Come on, Lindsay.
Because the y coordinate of the derivative will give us the tangent slope of the first equation.
Very good. The y coordinate of the derivative will be the tangent slope of f. How many knew that? 2 points. So let's find the derivative. This one's going to take a bit of work, so I'm going to go down the page here. So make sure I have good notation. So f of x is equal to, is it x multiplied by 1 minus 2x cubed? Is that correct?
Yes.
So here we go. It's the second function multiplied by the derivative of the first. The derivative of the first is 1. Just wave at me if you need to see more detail. Just go like this. For motion, not seeing any. Then I take the first function and I multiply by the derivative of the second. So bring down the 3. 1 minus 2x, that becomes squared. I must take the derivative of the 1 minus 2x. Let you catch up in your notes. Please.
Wait, what's the first part that's being added for?
So to find this derivative, I had to use the product rule, where I have this multiplied by this. Oops. So I took the second function, wrote it down. That gets multiplied by the derivative of x. But dx over dx would simply be 1. Is that your question?
Yeah.
2 points. Anything else? Awesome. So keep going here. So f prime is 1 minus 2x all cubed plus, this is going to become negative 2. Go like this if you need more detail. So the rule is I have 1, 2, 3, 4 things being multiplied. I choose the order. So negative 2 multiplied by 3 is negative 6. Like that. Questions? Cool. We have an equation for f prime. We can factor, we don't have to factor because we're just going to use the equation. But just as a little bit of practice together, I'll factor it. So the common factor is 1 minus 2x all cubed. Factoring means we divide. This divided by this would leave 1 minus 2x. Need more detail, go like this. Go ahead, Trey.
What happens to the negative 6x?
Oh, sorry, just haven't got that far yet.
Oh.
You're perfect. 2 points. No, you're perfect. Anybody else? So then I have plus. Now I divide again. All of this divided by this would leave negative 6x. Pretty excited about the color coding on that one, so question? We need more talk, Allison?
Is it wrong if I just plugged in the 1 for the
Nothing wrong at all. In fact, I probably would have done the same. I'm just doing factoring just as kind of a little extra practice, that's all. So, please, Matt.
We combine the negative 2x and the negative 6x then?
Huh? Because these two parentheses serve no purpose. Nothing is multiplying on what's inside the parentheses. There's no exponent. So we can say this is now f prime of x. Points for Maddie. Okay, show me your hands if you know what the purpose of this formula is. Hands up. What's the purpose of f prime? We have an f formula, we have a formula for the line, we have f prime. What's the purpose of the f prime equation? Go Maya.
Just plug in the x value, you can find the slope and put it in the h of x equation.
Slope, so we can take the f prime equation, let's rewrite it up here. So f prime looks like this. Is that correct? So that's f prime. If we plug in an x into f prime, we can find the tangent slope of f at that x value. That's the purpose of this. I'm going to need to say that again. You must take, really, you have to know that the purpose of this is to find all the xy pairs of f. Purpose of this, find all the tangent slopes of f. You've got to keep it straight. Okay, this also finds the xy pairs on f prime. Purpose of this equation, find all the xy pairs on the green line. Okay? Don't ever make the common but critical mistake of thinking this is f prime. The green is not f prime. Brennan?
Last time when we did work that you had that h equation thing, it was like when there was a perpendicular line. So does that h thing just apply to like anything?
Smart. This is the equation of any line. I'm using it for the green line, but it's any line. Yep, it's perfect. Please, Rich.
So you're using the equation to find the tangent slope at what point? The tangent slope of f or the tangent slope of x at that point?
We're looking to find the tangent slope on f
On f.
at x equal 1 comma negative 1.
Okay.
Perfect. 2 points. 2 for Brendan. Please, Cass.
I know you already said this, but how did you get from when you took the derivative of f of x, why did you just pull out 1 minus 2x cubed? I know you already said it, but
You're okay. Why did I factor out this?
no, like on the second line.
Oh, right here.
You know,
Right here.
Yeah.
Oh, my bad. So I'm using the product rule to find this derivative. So,
Product, okay.
you see it now?
Yeah.
2
I was
points.
like, it's not constant, so.
You're fine. Yeah, it's not the constant rules.
Okay.
Anybody else? Awesome. So come back up here. So I go find f prime now of Mikkel, to answer the question you asked me one-on-one a minute ago. Most of the time when you find a derivative formula, the derivative formula will only be in terms of x. But sometimes you end up with a derivative formula that is in terms of both x and y. So in this case, we only need the one right now.
Okay.
Sometimes you'll need both. Does that make sense?
Yeah.
Make sure whenever you remove an x, you replace the x with parentheses. That prevents a lot of mistakes. Okay, question for the whole room. Please raise your hand and tell me, what does that box mean? Come on, hands up. What does the box mean? If you're not raising your hand, make flashcards. What does the box mean? Mikkel?
That's the final answer of what is the value at f prime of x. I mean, sorry, that did not make sense. The value, that -7 is the value of f prime at x equals 1.
Oh, absolutely true. 2 points. This is definitely the value of f prime when x equals 1. What's the second meaning of this? Hands, come on. You have to know both of them. Isaac?
Is that the slope of the line, of the first line at x equals 1?
So words I want you to adjust just slightly to make it a little more clear. So this is the slope of the curve f, we'll call it a curve, at x equal 1. How many knew that? 2 points. So this box here represents the tangent slope. Remember, f has many tangent slopes. So this is one of the tangent slopes of f. And which one is it? The one that is located at an x-coordinate of 1. So my drawing doesn't make sense. Raise your hand if you know why. Hands up. Like, why is my drawing? I mean, it was just a random drawing anyway, but it doesn't make sense, actually. Now that I have some numbers, I can say, oh, wait a minute, that can't be right. Like, what's wrong with my drawing, Heather?
It's like, you could say the slope's a positive 7, like
You're perfect. So knowing that, I really should have drawn something like this and said, oh, I'm looking for this tangent line because this slope here is equal to -7. It doesn't really matter, but everybody saw it? 2 points. Questions?
Please, Hayden, when would you use like both x and y? Like when will you plug in the negative?
Gotcha. If you start out with an equation for the curve, 2 points for Hayden, this is a good question. If you start for an equation for the curve that looks like this, right here, where x and y are all just kind of intermingled, by the time you find the equation for the derivative, right here, it's most likely going to require both the x and the y coordinate. Does that make sense? Whereas on the problem we were working on, the formula for the curve is only in terms of x. Therefore, the formula for the derivative will also only be in terms of x. That's the difference. It's a really good question for your point. Anybody else?
I have a question.
Oh, please.
So on the other one where it's the x and the y are both in the equation, do you use the y from just half of x, the y coordinate from just half of x? Does that make any sense?
Yes. Think of it this way, Danny. Back here. Okay, let's pay the whole room just to answer your question. Hands up if you know the purpose of this equation. Come on, show me hand. What's the purpose of this equation? Sarah?
Give you a list of different outputs.
That's it. It's just a list of x, y values. Somebody knew it? Point 2 for Sarah. So this is my list of x's and y's. So the x and y you see here represents some x, y point. A whole bunch of them, but you need one of them, okay? when you work the derivative, you're working with that same x and y, so the meaning is no different here. The x and y you see here still represents some point. Is that your question? Not really. Keep going.
Well, so, I don't know, I'm trying to think how to say it. So like, on the other one, you know how we just put in a 1 for x, right? So would you have to put in, since the point was 1, comma -1, would you have to put in 1 for the x and then -1 for the y?
So if we had worked out, like we wanted to find the slope of this curve here at an x-coordinate of 1 and a y-coordinate of -1, as long as that is a point on the curve, we would plug in x equal 1 and y equal -1 into the formula.
Okay.
Is that your question?
Yeah, that was fine.
In this case here, maybe this would help. Anytime you have a function, the pairs are always matched. So in this case, this -1 is always linked to the 1. So even though all I plug in here is 1, I'm essentially plugging in -1 for y. Like they're inextricably linked. So,
Okay.
is that your question?
Yeah.
Okay. Anybody else? Yes.
So then to finish this off, we would plug in -7 to n.
So I come down here and say, let's use this space over here to work. So the equation of the line tangent Oh, gotcha. Perfect. So, don't let me forget the question. Is everybody good to hear? So, we should have to know what the purpose of that equation is. What's the purpose of that equation? So, Elijah?
Isn't it the equation at that point for the f, or the h was?
It is what I called h. It's the equation of that line. So what's the purpose of that equation? You're fine. Like it is the equation of that line, but what do we mean by it's the equation of the line, Ellen?
It's the list of inputs and outputs with the tangent of the lines.
Perfect. It's just another list. So we now have on the board 3 different infinite lists. We have the list of f, which is the points we drew here. We have the list of f prime, which is all the tangent slopes of f. And we have the list of this thing here, which is every point on that green line. It's perfect. 2 points for Ellie and Elijah. Question? See your question here?
Why don't you use the negative reciprocal for n?
Oh, gotcha. So where that comes up is if they said the line normal.
Oh.
A line that is normal to a function is a line that is, hey, perfect for the data physics teachers here. A line that is, sorry, joke. A line that is normal to a curve is a line that is perpendicular to the tangent. So testing everyone, if the slope of the tangent line is -7, please raise your hand and tell me what's the slope of the orange line. Allison? +1/7. How many knew it? 2 points. Okay. That is your question, Sarah. Okay. Other questions here? Please, Isaac.
Can we simplify the equation of the line tangent? And all that?
Glad you asked. So, if this is a free response question, you just want to stop here. Okay? If it's multiple choice, it must match their answers. Okay, they will give you the answer in one of 3 formats. The format, I guess 4, sorry. The format may look like this. Sometimes they move this number to the other side. So that's one possible way that all the multiple choice answers will be listed. Here's a second way. Any questions on how those are equal? Please.
Why would they do that?
I can only guess. I've seen some textbooks that say this is the point-slope form of a line. I've seen other textbooks that say this is the point-slope form of a line. So the test writers seem to have decided that, well, we'll just kind of do all of them. And I don't know. Point, please.
Is there like a way that for us to find well, like on the thing we see that A is -7, that's the only one with -7 slope, but are we going to find out where that 6 comes from, or do we just know because of the slope?
No, you're good. Here's what you should do. Okay, whenever you're finding an equation of a line, any line, on the multiple choice section, okay, free response, just stop. But on the multiple choice, when you get to here, think, oh, that's right. Another way they might write the answers to move the 1 over. They might also just distribute. So they might do this. So the blue equation is also a possible answer. Question? Elijah?
Does that turn into y equals the slope of the x plus the y-intercept?
Correct. So what you learned in previous classes was this is known as the point-slope form of a line, because what you see is the point and the slope. The point is over here. The slope is here. Then this is what you learned was the slope-intercept form of a line, because you see the slope and the y-intercept. Does that make sense? 2 points. The third way you will see the answers depicted in a multiple choice test is this. They rearrange so that it's x plus y equals number. So any of those could show up as a multiple choice answer. You have to be prepared for all of them. Question? Awesome. Cool. Okay. Go to number 51 in the back. Okay, I'd like everyone to work on 51. I'll walk the room. We're going to talk about it in a minute. Go.
What, sorry?
I believe so.
Okay, show me your hands if you got it right. Show me your hand. Who's able to work the problem correctly? Like, look at all the work. Look at all the work. You don't need to show everything I showed. That, like, this is all explaining to people, but like, who is able to get the correct result for this problem? 2 point question, please.
So on the line that you drew, the green, I didn't have any lines that were perpendicular. Like, what's
No,
that?
no need for that. You're perfect, Brennan. The only reason I drew the perpendicular line is because someone last period
Okay.
asked that same question again, like, oh, wait a minute. What would the line normal look like? And I'm like, okay, so here's the line normal.
Yeah, this is the exact same thing we used the last question, except we were given the derivative.
It is. That's perfect. Okay, everyone. One key to doing well on the next test and the AP test is to do what Brennan just did. To recognize that the problem we worked, number 20, is in concept identical to number 51. They're the same problem. You have a function, you're trying to find an equation of a line tangent to that function. The only difference was they made it easier. They gave you a formula for the derivative. So you already had the formula you need to find any tangent slope on h. They gave you the points you need, so it was a matter of just plugging it in. So, please.
Where did you put a 1 underneath the x and like before?
Over here. So the reason I did that, everyone look, that makes sense of this, look, is I was demonstrating last period the same thing I just showed all of you on problem 20, that on a multiple choice test, this may not be how the answer is displayed. They might distribute. And some people had trouble remembering that when a fraction gets multiplied, this is still a fraction. So you'd end up with this. That's why the 1 is there. Anyone having trouble getting from here to here? You have to do this in the homework, you have to do it on the test. So if it doesn't make sense, wave at me. Pretty good? Then these two can combine to here. So you might see the answer in this form. You might see the answer in this form. You might also see the 3 added to the other side. So that's 3 different ways they can display the answer. They might then go to standard form. In standard form, the coefficients of the x and the y will not be fractions. So they will multiply by some value to get rid of the fraction, to get to the blue version. Anybody need me to do that again?
So do you just have to like get good at, once you get rid of all the like derivative signs and everything, you just have to look at the multiple choice answers, you just have to like mess around with it until you get it?
What I do is actually really sequential. I don't, like, good question.
How do you know where to go?
No, I don't mess around at all. What I do is I say, hey, this is my, that sounds good, I don't mess around. Is that how you say it? Like, I'm so much older than all of you that like I feel like I'm living with like in a different country, and that if I say the wrong thing, you'll all laugh because maybe I'm saying something inappropriate, and I won't even know. Am I okay? Safe? Thank you. All right. I trust Maddie. She would be honest with me, right? Thank you. Okay, good. Look, hey, don't mess around. That sounds good. Okay. Never mind. All right. If you're doing free response, hey, if you're doing free response, just stop here. Don't do anything else. Next step, look at your answers. If they have parentheses, then it's going to be in this form, or the 3 will have been added over, nothing else. There will not be any other options. So the answer will either look exactly like this, or they'll just move the 3. Okay? If the answers have no parentheses, distribute and see if that's the answer. Last thing is, if all the answers are x plus y equals something, then arrange yours so it's x plus y equals something. So now I just do it in sequence. 2 points for Brendan. Good question. Anyone else? Solid. Do 52, please. Go. Do 52, please. If you want to ask something, just feel free to stop me. Hey, raise your hand. You got this one, right? Who was able to solve and get this equation of the line tangent? 2 points. Just so you know, hey, notation is critical in this class. But as a contrasting example, if I were doing this on the AP test, this exact free response question, which was actually given in 2003, and I wrote this green box and I wrote nothing else, I would get full credit. Because there's nothing to do. Like, it's simply understanding that Every one of these y values is a slope of f. That's all. You just have to know that. So. Good work. Okay, don't forget. Start of class on Thursday, we run the Scantrons for this packet. That's your score, okay? Questions? Go to work. Oh. If you have a good question for me, just stop me. Extra credit opportunity in the whole room. Okay, look. The next test and the AP test, of course, are not about memorizing problems. They're testing you on concepts. So far in this packet, this is the best one I've seen. To see if you understand concepts and have not just memorized problems. So let's interact together. I'll give you some extra credit. Let's see how well you can do. You must read AP questions like 5 times slower than you are used to reading AP questions. One of the biggest mistakes people make is they read so fast they don't even know what the question said. So here's an equation. Hands up if you know what the equation is for. Like, what's the purpose of this equation? Show me your hand. What's the purpose of this equation, no? Yeah, so I kind of need a picture on that one. So I've got some graph F. I've got a tangent on F that goes through 1, 4. Shoot. No. Just relax for a few minutes. Okay. There we go. Okay. We've got this line. Then there's a normal line, like so. And Noah's correct. This is how you find every XY pair on that normal line. Hands up if you knew that. Points. Well done. Then they say f prime of 1. Hands up if you know what that means in English. We're supposed to find f prime of 1. What does f prime of 1 represent in English? You know what it represents in Mandarin. I'm okay with that as well, but you know. Nice. Not really. I have to bring in one of my 2 sons. So Ellie.
It's the slope of the x-coordinate stuff.
Correct. Just a little more detail. Just say it with more details.
So it's the slope.
Slope of what?
Slope of the line.
Of
the
which?
Tangent line.
Tangent line to what?
To the curve.
Curve of what?
Of f.
There we go. You're great. So this is the slope of f. So let's write it down. So this is tangent slope of f. Keep going, Ellen.
When x equals 1.
Perfect. The key thing is the key thing I wanted Ellie to say and everyone else to say as well is always, tangent slope versus secant slope. Tangent of what? Where? Perfect. How many knew it before she said it? 2 points. 3 for Ellie. Please, please.
I'm confused on where you get the red line.
Say again.
The red line, I'm confused where you get that.
Gotcha. So it said if this is an equation of a line, so it's equation of some line, get me there, and it's the line that is normal. Normal means perpendicular.
Oh.
No worries, just a flashcard. You know. Keep going. So normal to F. So I drew my guess of what F looks like. At 1, 4, I drew 1, 4 on F. Normal means perpendicular to the tangent. So I drew the tangent and the normal. You have to have both.
Yeah, I get that.
You're good. 2 points. Someone else? Hands up if you know how to find the slope of the red. How do you find the slope of the red? Weston?
Put it in y equals mx plus d1.
Smart method.
And then
Let me just catch up here with you. You're okay. How many knew that before you said it? 2 points. Anybody have a different idea? Please.
I would say find the tangent line because that's the same, it's h, x, m, x, that tangent, it's that equation, and then you just flip the m value that you get.
No, that's perfect. It really is. Do you have a way of finding the slope of the brown? You're doing perfect.
You would just find the derivative of x plus.
This thing here.
Yeah, you find the derivative of
So let's just 3 points. You're doing 4 points. 5, mark them down. No, really, Mikhail, you're doing perfect. I just got to readjust your thinking just a little bit because you are making a small mistake. So the first part that you said was perfect. That if you find the equation for the brown, you'll know the slope of the red. Just that quick, right? Okay. If I take the derivative of this, however, this is the red line.
Oh, that's the red line.
Is that okay?
Yeah.
So if I take the derivative of this, that's why I gave you 5. It's really good thinking. If I take this derivative, the derivative of x is 1. The derivative of 7y is 7y prime. And that's equal to 0. If I rearrange,
1 over 7.
negative. So the slope of the red line is negative 1/7. Do you see that?
Yeah. Oh, so you would just flip it then?
Change the sign.
Yeah.
So they get it here too, watch. Because now I divide both sides by 7. It's really super well done. So this becomes negative 1 over 7x plus 29 over 7. So either method tells us the slope of the red line is negative 1/7. Therefore, the slope of the tangent is 7.
So I understand it, and I have
Does that make
the
sense,
same
Mikhail?
answer.
Yeah.
Oh, sorry.
You're good.
Because I did the y equals mx plus b, but what's the difference between the orange and how you just got that? And
So the method's here and here.
yeah, because I understand the y equals mx plus b, but I got a little lost when you did the
You're okay.
other one.
I'm trying to get everybody to do, look, all eyes here, look, all eyes here. There's a pattern that emerges, and that's that some people are just so good at like always asking when it doesn't click. And it translates to really high test scores, it really does. So just keep doing it. So you're good here, right? Awesome. Okay, whole room, get extra credit on this. When you take the derivative of any equation, what are you finding? Hands up. You take the derivative of any equation and then rearrange so it says y prime equals. What are you finding? Hadley? You're finding a formula. You're doing great. You're finding a formula that will tell you the tangent slope of the original equation. One more time. When you take the derivative of any equation, you're finding a formula that will compute the tangent slope of the equation you took the derivative of. How many knew it? 2 points. So that's what we did. We said we're going to take the derivative of this equation. Turns out to be negative 1/7. Therefore, the slope of this equation is always negative 1/7.
Because, wait,
Keep going.
if that's the derivative of y, but we were finding the derivative of x plus 7y equals 29, how is that the slope on that line?
So you're going to click here in just a second. I just got to keep talking, okay? So Rachel, what is the purpose of this equation?
That gives you the x and y values on the red line.
Perfect. And if we take the derivative of this, we get a new equation which gives us the tangent slope anywhere on this line. You okay with that?
The tangent slope on the line.
Right there?
Yeah.
Yeah, that's what derivative means. So we'd be finding like the tangent slope here, or here, or here, or here. But a line never has, the slope never changes. That's why when we took the derivative of this, the result is negative 1/7.
Okay. That makes sense.
You good? Perfect. Anybody else? Sarah did that.
Yeah, I figured out the same thing, but I just tried to like double check my answers, so I took out, that's my sense, I took out the n, so to get to its original equation. So I got negative 1 over 7 in parentheses x. And from the 29, I tried to separate out the 4.
Oh,
Minus
interesting.
25 plus 4 is to double check, but I don't know. Like,
So
the
you-
25 is supposed to be 1.
So you're saying you tried to figure out a way to make this look like this?
For the, like, the equation point too, yeah, I tried to make it look like n parentheses x minus x1.
Oh, gotcha.
Oh, yeah,
I don't know that you can do that. Well, you can do it with this extra information here. Like, I know that the equation of the red line is this. So the line normal is going to be y equals negative 1/7 x minus 0, no 1, sorry. Like that?
Yeah, except for I did it, how we were talking about before, like this 29 over 7 is just 25 over 7 plus 4. So I try to separate that.
Are you trying to make it look like this? I might have to play it. I've never tried to do that. That's interesting. It will work. Sorry.
Your counselor, the LP.
So I would just go down the list.
In room 117.
Let's see.
Gibby loves you, so he's giving you until November 15th to turn in your senior quote.
They give me a limit. They ask if the
Don't disappoint him.
derivative
Get your quotes
exists.
in before the
I'm not
15th.
sure, so I'm going to skip that one for now. Then it
There
says,
will be
is
a
f
national
continuous at
honor
x equal
society
a?
this
I can
Wednesday.
answer that because I have a flashcard that reminds me of the following.
Alright,
Yeah.
next we hope you have a wonderful Tuesday, and remember, power to the peak.
Is continuous at x equal a if the limit,
Thank you.
you're welcome, as x approaches a from the left is the same as the value of the function at a is the same as the limit as x approaches a from the right. Does that seem familiar? So you need to have that flashcard for sure. So all they're telling me is that the limit as x approaches a is L. So I know that this is equal to L, and this is equal to L. Otherwise, they couldn't tell me that the limit was L. But they didn't tell me what's happening at f of a. So this one here could be true. Like, I don't have any reason to say that it's false, but I do not have enough information to say that it must be true. You with me?
Yeah.
Want me to keep going?
Yeah.
Okay. Is f defined at a according to this?
Yes.
Not necessarily. The limit is only talking about what's happening a little bit before a and a little bit after a.
Oh,
Yeah, the limit doesn't reference what's happening at a. So this one here is also could be true. I do not have enough information to declare this to be false or true. I don't know. Same thing. Does f of a equal L? I don't know. Could. Doesn't have to based on this data. Look at that. Well, if I don't even know if the function exists at a, I can't say that the derivative exists at a. So none of the above.
okay.
Good
Just
job.
confused me because I felt like